Okay, now let's start part 2 of this practice paper, and again this has a difficulty level of 1. Okay, so these questions are the basic type of questions, so make sure you know them very well. Starting with question 11, it says simplify this expression here with positive indices. So in this question, all you need to do is find the like terms and try to cancel it down if you can. So you can see that 3 and 9, I think they're both factors of 3, aren't they? So 3 divided by 3 is 1, 9 divided by 3 is 3. Okay, so just cancel them down. And then look at the x. There's common factors of x, but this one is x to the power of 6, x to the power of 2. So I can cancel this whole thing, and this will become power of 4 remaining. And now look at the y's. This will get a bit messy, but make sure you're following. Y and y, they're common. This one has a power of 3 and this one has a power of 7. So the lower power one can actually be cancelled out totally. And 7 minus 3 will become 4. Okay, so 7 will be cut down to 4. Now z, these are common as well. So I can cancel out this one here totally. And this one will just have 1 left over. Okay, because 4 minus 3 is 1. Okay, and the answer becomes, see how this is just 1, so I don't have to put that. X to the power of 4 is remaining. Z to the power of 1 is remaining, so just Z on top. And on the denominator, I have 3, and then y to the power of 4. And all the others were eliminated, were cancelled out. And that's the answer. So have a look. So this is a very simple question. Now if you like to use your indices skills, you can do, you know that 3 over 9 is 1 over 3, so I won't go through that one. But x and x, you can subtract the indices because this fraction means that we're dividing. When we're dividing, we subtract the indices. So you can go 6 minus 2 to get 4 for the power of x. And the y's, see how y cubed is smaller than y7? So this time you would do 7 minus 3 and put it on the denominator. Keep it on the denominator. So I have y to the power of 4 because 7 minus 3 is 4. And for the z's, 4 is bigger than 3, so you can, because we're dividing, you subtract the indices. So you do 4 minus 3, which is 1, so it's going to be z to the power of 1 on top. So that's how I get that answer. So this is just using some basic index rules. Okay, so that was question 11. Question 12. Subtract 4ab minus 3 from the product of these two expressions. So I'm going to find the product of these two, and then from that solution, I'm going to subtract this expression here. So if I write this out all together, I should have something like this. So multiply these two together, I'm just using brackets, okay? And I'm going to subtract 4ab minus 3. Now the key thing here, guys, is to keep your brackets. If you don't have brackets, I'm pretty sure you guys are going to make silly mistakes. Well, not all of you, but some of you at some point will make a silly mistake. Okay, so even if it's just obvious stuff, I still recommend you to keep brackets and add that extra step. Okay, so it's worthwhile doing that. Now let's expand. Okay, so on your next step, we'll expand. You should be able to expand this one. It should be 2a times a squared is 2a cubed. 2a times negative b is negative 2ab. 3b times a squared is 3a squared b. And 3b times negative b is negative 3b squared. Okay, so make sure you watch out for the signs as well. Now let's expand out this. And the reason why I'm telling you to keep the brackets is because negative 4ab is just negative 4ab, but negative 3 is positive 3, and people tend to forget that. So negative is positive, so it's positive 3 at the end. Now all I need to do is gather the like terms. So 2a cubed is left as it is. See how this one and this one is common? They're like terms of ab. So negative 2ab minus 4ab is negative 6ab. And then the positive 3a squared b stays there. There's nothing else common with that. Same with the negative 3b squared, and same with the positive 3. So eventually these are the only things I've gathered together because they're like terms. So that's the answer. So it's quite long, but that's all I can simplify down to. So have a look. And let's move on. Question 13, factorize 3x cubed minus 27y cubed. Okay, this has got some cubic numbers, and you should be able to change that into something like this. Because 8x cubed, and 8 is 2 cubed. X cubed is x cubed, so I can group that as 2x, the whole thing cubed, right? And same with 27, you should know that 27 is 3 cubed, and this is also got a cube, so you can make that into 3y bracket, the whole thing cubed. Okay, so I've changed it into a cube number minus a cube number. All of you guys should be able to tell me the rule for this factorizing these cubics. I'll just show you over here for those who have forgotten, but make sure you promise me you're going to remember them from now on. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. Okay guys, so write this down. I have gone through this in our lesson, so if you're clueless about this, make sure you watch the video on all this background information. So that's what I should use for this part. So see how a in this case will be 2x and b will be 3y. So just put in your values into this rule here. Okay, so it should be like that. So a minus b, it will be 2x minus 3y. A squared, which will be 2x squared, that will become 4x squared. And it's going to be all positive signs inside here. So positive a times b. A times b will be 2x times 3y, which is 6xy. And finally, plus b squared. B is 3y, so 3y squared is 9y squared. And that's it, you can't simplify or factorize any further. Okay, so that's the answer. So all I used was this rule here, so make sure you memorize that one. Okay, and guys, can you tell me the difference in the answer if this was a plus? Just so you can remind you. A cubed plus b cubed, guys, you should be able to tell me again. It's going to be a plus b, a squared minus ab plus b squared. Okay, so can you see the difference? This time this is a plus, whereas this was a minus, and this is a minus, whereas this was a plus. Okay, so that's the difference there, but I'm assuming all of you guys already know this stuff. Okay, if you haven't, make sure you memorize it. Okay, so that was question 13. Question 14. It says solve x squared minus 9x plus 11 equals to 0 and giving the solutions correct to 4 decimal places. Okay, now assuming it's telling us to correct it to 4 decimal places, so I'm assuming that this won't factorize, yeah? Because 11, the only factors are 11 and 1, and that's not going to make negative 9, is it? So what I'll do is just turn to our quadratic formula, and I'm not going to go through the quadratic formula. If you don't know what the quadratic formula is, you must watch the video explaining that one, okay? Because it's just so important. So I'm just going to go straight to it. It's going to be negative b, so b is negative 9. So negative 9 is positive 9, plus or minus square root of b squared. So negative 9 squared is the same thing as 9 squared, isn't it? So I'm just going to write 9 squared. Minus 4ab. So minus 4, a is 1, so I'll put 1 at the end, and c is 11. Okay, so 4ac. And the whole thing over 2a, so 2 times 1, because the coefficient of x squared, which is a, is 1. So got that, just put it into our quadratic formula, and then now just simplify. You should see that 4 times 11 is 44, 9 squared is 81, so 81 minus 44 is 37. So I've just simplified inside that square root. So guys, the answer is x equals to 9 plus root 32 on 2 and 9 minus root 37 on 2. Sorry if I said 32, root 37, okay? And because I need to correct it to 4 decimal places, I've got to put each and one of them into my calculator. So do one at a time. If I put that one into the calculator, I would get 7.5414, round it to 4 decimal places, so that's why that's the answer. And put this in your calculator, you should get 1.4586. So that's your answer there. all down to 4 decimal places. Okay, so remember guys, if you don't answer this part of the question, you do get marked down, so make sure you take an eye on that one as well. Okay, that's the answer guys, just simply using the quadratic formula. Question 15, expand and simplify. Okay, I'm going to expand and simplify this one here. So it's this whole thing squared, so it's going to be expanded just like that. Now for those who are not good at going straight from here to here, you should know that a minus b squared, okay, it is a squared minus 2ab plus b squared. You might like to memorize this or think about this and then try to insert your values in, because in this case a is root 13 and b is 4. Okay, or if you really like to, you don't have to go like this, you can change this to root 13 minus 4 times root 13 minus 4 and go one by one. So do root 13 times root 13, then root 13 times minus 4, then minus 4 times root 13, and then minus 4 times minus 4. Do one at a time if you need to and add that extra step, okay? As long as you know that you have enough time, that is. But I really like to, a lot of you get used to this method of going straight to the answer. So I'm actually going to show you this way. So in this case, a is root 13, so root 13 squared is just 13. Now minus 2 times ab, so it's going to be minus 2 times root 13 times 4. Root 13 times 4 is just 4 root 13, times 2 will be 8 root 13. Make sure it's negative out the front. And then finally it's going to be plus the b squared. So b is 4, so it's going to be plus 4 squared, which is plus 16. And that's it. So all I need to do is gather my like terms. 13 and 16 will become 29. So 29 minus 8 root 13 is your final answer. Okay? So there's a little bit of expansion there. Make sure you know all this stuff. Okay? I'll rub that off. So just be careful when you're doing this question, guys. That's question 15. Question 16, okay, we're going to rationalize the denominator for this expression. So make sure you know why we are rationalizing first. Rationalizing, as I've said in our video of basic arithmetic and algebra, its point is to get rid of that surd on the denominator, because it's difficult to work with fractions that have surds on the denominator. So to rationalize, make sure you remember we multiply the top and bottom, basically the numerator and denominator, by the conjugate of root 3 minus root 2. Now the conjugate is simply when you switch that sign around to the positive. Okay, so I'm going to multiply top and bottom by root 3 plus root 2. That's the conjugate of root 3 minus root 2. So the only difference is that the signs have switched. Okay, and make sure you do it to both numerator and denominator. Okay, because if you're doing something to a fraction, you must do it to both top and bottom, right? Just some obvious stuff. So I'm going to do that. The top 1 times root 3 plus root 2 is just root 3 plus root 2. And then this one, guys, it's a square number, well sorry, not, it's a number minus a number times a number plus a number. Remember guys, a minus b, a plus b is a squared minus b squared. Or vice versa, when you want to factorize a square minus a square number, you go this way, right? So I'm going to do that. So I won't go through all that long expansion. I'm just going to go straight to this step. So in this case, a is root 3, b is root 2. So it's simply going to be root 3 squared minus root 2 squared. Okay? So root 3 squared is, root 3 squared is 3, root 2 squared is 2. That's why I get 1, okay? Because 3 minus 2 is 1. So I don't really need to put anything over 1. So the answer is simply just root 3 plus root 2. Okay, because there's no point of having the 1 on the denominator. And that's the answer, guys. Have a look. Okay, make sure you know this. This is just some simple stuff. Okay, that's question 16. Let's move on. Question 17. Again, it says rationalize the denominator of this expression. The only difference is that it looks a little bit more confusing. Okay, so let's get started. So again, we have to multiply top and bottom Okay, so numerator and denominator by the conjugate of the denominator. Now the denominator is 3 root 6 minus root 2, so the conjugate must be 3 root 6 plus root 2. So you do that to top and bottom. Now be careful when you're expanding this, it's easy to make some mistakes, so just go step by step. I like to keep brackets around so I can just like lead my way through. So I'm going to go like this. So this is what I've done. So I've done root 5 times 3 root 6, which is going to be 3 root 30. Make sure you know that you can multiply these thirds together and make it root 30. So 3 goes out the front, root 5 times root 6 is root 30. And then you do root 5 times root 2. Root 5 times root 2 is root 10. Again, you can multiply the insides of your surds, so root 10. And then now I'll do 1 times 3 root 6, which is just 3 root 6, and then 1 times root 2, which is just root 2. Okay, luckily they're all positive, so you don't really need to worry too much about the signs. Okay, it's all going to be positive. So that's for the top part. So I'll rub that out. And now for the denominator, have a look. It's 3 root 6 minus root 2 times 3 root 6 plus root 2. Plus root 2, okay? So we need to do the difference of two squares thing again. Because see how it's the same thing? Root 3 root 6 minus root 2, 3 root 6 plus root 2. So I can simply just do 3 root 6, the whole thing squared, minus root 2 squared. So 3 root 6 squared, I can change it to this, 3 squared and root 6 squared. You've got to square both of them, and root 2 squared. So now all I need to do is simplify it, just like this. So, see guys, I've left the top as it is because there's no like terms, but the denominator I'll simplify first. 3 squared is 9, root 6 squared is 6, okay? So I'll just write that for you if you need to. That's 9. That's 6. Okay, 9 times 6 is 54. And you should all know that root 2 squared is just 2. So that's how I've got that. And then 54 minus 2 is 52, to simplify it, and that's just my final solution. As you can see, there's no other like terms, so I can't simplify any further than that. Okay, and that's pretty much it. And some of you like to try and simplify some of these surds, but you should realize you can't simplify them any further. So that's my simplest form in simplest surd form. Okay, and see how the denominator, there's no more surd, so I've actually successfully rationalized the denominator. Alright, so that was the end of part 2.